Hey all, let's tackle this problem from class, the integral from -2 to 0 of 3x squared minus x dx. We're going to solve this using Riemann sums because right now that's the only technique that we have to solve it. So remember that means writing out the limit as n approaches infinity of the sum from I equals 1 to n of f of a plus I delta x times delta x. We know delta x equals 0 minus -2 over n, which is 2 over n. We also know that a equals -2. And we know what f of x is, right? It's 3x squared minus x. So this is going to be, let's be a little careful here, 3 times -2 plus I times 2 over n. Quantity squared, right? Because x is squared. Minus -2 plus I times 2 over n, right? 3x squared minus x. And remember, don't forget, multiply all of that by 2 over n, by that extra copy of delta x, right? Just to be clear, this is our f of x. This is our extra copy of delta x. Okay. So now what I'm going to do, the rest that we're going to do up until this point, up until toward the end, is just a bunch of algebra. We're going to square, we're going to FOIL out that -2 plus I delta n part, or I delta x part. And then we're going to combine like terms, then we're going to multiply through by 2 over n. Okay, just a heads up. Warning, arithmetic ahead. 3 times, and I think this is 4 minus 8, or actually I'll say, I'm going to put the number over n in front of the I, so I think it's going to be 8 over n times I plus 4 over n squared times I squared. I'm just going to distribute that negative sign right now. All right. So I just FOILed that inside, and now I'm going to multiply by the 3. Oh, put this right here. Multiply through by the 3, and then combine all the like terms, okay? We're going to get 12 minus 24 over n I plus 12 over n squared I squared. Plus 2 minus 2 over n I times 2 over n. Okay, now I'll combine the like terms, right? So I think we've got a 12 and a 2. We've got a -24 over n I, -2 over n I, and then we've got that other last term. So it looks like we're getting 14 minus 26 over n I plus 12 over n squared I squared, all times 2 over n. Just be clear where our numbers are coming from, right? Okay. Next up, distribute through by the 2 over n. Just be a little careful. Remember that you're multiplying everything by 2. Oh, shoot. Sorry. Little typo here. Seem to have dropped my summation symbol. So if you were quick to have caught that, then excellent. Excellent. Let's shrink her down a little bit there. Oh, my bad. Shrink her down a little bit right there. Right, okay. And then maybe we'll just keep pasting this guy, right, so we don't keep forgetting him. Awesome. Sorry about that. Okay, now remember, at this point, multiply the top by 2 and make sure to divide the bottom by n, right? So I think we're getting 28 over n minus 52 over n squared I plus 24 over n cubed I squared. Okay. You should know this because, right, the degree of n on the bottom should be 1 more than the degree of I on the top. Okay. Now, at this point, we're going to do something that we get to do because the series is absolutely convergent. I don't want to dwell on that definition. It's a little bit technical. But basically, because our term doesn't go to infinity, because it converges to a number, and because it does so in a nice sort of way, what we get to do is write our summation sign for each of the terms. We get to, in a sense, distribute that summation sign to each of these terms. Now, really, you could say, well, wait a minute. Aren't we just choosing the order in which we add up our numbers? Yes, we are. And you might say, well, isn't that just the commutative property of addition? Yes, but you have to be careful when things are infinite, when you have an infinite number of terms. It doesn't always work out that way, believe it or not. If the sum is divergent or if it's conditionally convergent. Don't worry about that right now. Just keep it in mind that it's notable that we get to do this, that we get to distribute the sigma out in each case, or in each term, okay? Okay, so now, right before we use our identities, look, if you can see the identities at this point, then please feel free to use them. But what I always like to do is I like to get the sigma by itself. I take all the n terms out. All right, and last but not least, we have this guy. Right, all we did was we took out the n terms, the terms with only n outside the sigma. And we get to do that because n does not depend on the sigma. Only I depends on the sigma. N depends on the limit. We can't take it outside the limit, but we can take it out of the summation. Now, at this point, we have some identities. The first one is a little bit new, right? But it's one that you can think about. What's 1 plus 1 plus 1 plus 1 n times? It's n. Right, whoops, I don't know why. Sorry, there's a little bit of a typo right there. I don't know why I had that. This is 52 over n squared times, now remember this one, this was n times n plus 1 all over 2. And then this last one, remember we did this one in class today, n times n plus 1 times 2n plus 1 all over 6. Okay. And at this point, if you can take the limits, then great, right? Notice, of course, that here the n's actually cancel. In fact, here an n cancels too, and even here, an n literally divides out very nicely. Okay, right, or perfectly divides out very nicely, maybe I should say, right? So anyway, I'm just going to take the limit at this point, right? We're getting 28 for the first term minus 26 for the second term, right? 52 over 2. Plus 24 times 2. Don't forget about that 2 right there. That's 48 divided by 6 is 8. So it looks like our final answer is 36 minus 26, which is 10. If we go ahead and just check our answer using Desmos, hoping we will see the that same sort of thing here, right? Getting the integral from -2 to 0 of 3x squared minus x. I think we need to write dx. Oh, it's not liking that. Give it a space, maybe. Let's see really quickly if we can get away with this if they have... I might need to just do a space myself. See if it lets us do that. Nope. Try this one more sec. It's not going to give it to us, then that's a bummer. Here we go. Oh, I see. We needed parentheses, I think. And you see, our answer is, in fact, 10. All right, so there you have it. Okay, we did it correctly. Thanks for watching.